So here we're going to simplify trig expressions and look at proving trig identities. So the first problem we're looking at is secant x divided by cosecant x. The first thing we want to do is put everything in terms of sine and cosine. So secant x is 1 over cosine x, and cosine. Our next problem is 1 over 1 minus cosine x plus 1 over 1 plus cosine x. So we need to get a common denominator to combine our fractions. So when we multiply these by each other, we actually will end up with the difference of squares. So we'll have 1 minus cosine x times 1 plus cosine x plus 1 minus cosine x times 1 plus cosine x. Now the numerator was 1. We multiplied this denominator by this to get our common denominator here. So we have to multiply it by that again. So 1 plus cosine x. Now, you don't really have to write it completely this way because the 1 isn't going to change anything, but in case you have something else on top of it, I want to make sure you understand that you would multiply by whatever's up there. So the same thing will happen over here, but in this case we multiplied by 1 minus cosine x to get to our denominator. So what we do to the bottom, again, we need to do to the top, so 1 minus cosine x. Basically, we end up multiplying by 1 and by 1 on each part. They just look a little bit different. So this will leave us with 1 plus cosine x, because the 1 won't change anything, plus over here we have 1 minus cosine x divided by our denominators. So 1 minus cosine x times 1 plus cosine x. So when we get to this spot here, our cosine x's are going to cancel because they're plus and minus. So we end up with 2, and our denominator, we can multiply it out. So 1 times 1, or 1 minus cosine x times 1 plus cosine x will actually be the difference of squares. We'll end up with the 1's being multiplied. The middles will cancel out. So we're going to end up with 1 minus cosine squared x. From our trig identities, we know that 1 minus cosine squared x actually equals sine squared x. We can rewrite this to look like 1 over sine squared x times 2, and 1 over sine squared x is going to become cosecant squared x. All right, our next problem we're going to look at is cosine x times cosecant x divided by cotangent x. So again, I'm going to start this the same way by writing everything in terms of sine and cosine. One of the things I'm going to do is I'm going to write my cosine x over 1 so that I can keep track of if it's in the top or the denominator or the numerator part of our fraction. And cosecant x will be 1 over sine x, and our denominator, cotangent x, will be cosine x over sine x. Well, if I put this top together, I end up with cosine x over sine x divided by cosine x over sine x. Well, you could take this and not divide by a fraction and multiply by a reciprocal, but understand if you have the same thing on the top divided by the same thing on the bottom, that's equal to 1. And that would be the end of that one. So some of your simplifying will be very short and some will take a little bit longer. The next one we're going to look at is actually proving an identity. And the difference is on the expressions, we don't know what the other side of the equation looks like. We have this, but we don't have this side over here. So when we're proving them, it can be a little bit easier. It's also usually a little bit more complicated. But we know what the other side looks like. So this time we're going to do tangent theta plus cotangent theta equal to secant theta times cosecant theta. You have to pick which side you want to work with. We're going to do this one because it's addition. And what I'm going to do before I start, because we're going to again go to sine and cosine, I want to know what this is going to look like at the end so I know where I'm trying to go. So I'm going to just rewrite this. It's going to be 1 over cosine theta times 1 over sine theta. Because secant theta is 1 over cosine and cosecant is 1 over sine. I'm doing this so I know where I'm trying to get to. It makes it a little bit easier. So we're going to start with our left-hand side, which is our tangent theta plus cotangent theta. And I'm going to start out by writing everything in terms of sine and cosine. So tangent will be sine theta over cosine theta, and cotangent will be cosine theta over sine theta. Well, with this, again, I still need to get a common denominator. So my common denominator will be cosine times sine. So I'm going to multiply this side by sine over sine and this side over here by cosine over cosine to get that. So we'll have sine theta over cosine theta times sine theta, and I multiplied the bottom by sine theta, so I have to multiply the top by sine theta. Plus, over here we'll have cosine theta times sine theta, and I already had cosine theta, but I didn't on the denominator. I did not have that, so I also have to multiply it by cosine theta. So again, we multiplied each one by 1. 1 just looks different for each case. So now we have sine squared theta and plus cosine squared theta all over cosine theta times sine theta. Well, with our trig identities, we know, with the Pythagorean identity, that sine squared theta plus cosine squared theta equals 1 over our cosine theta sine theta, because sine squared theta plus cosine squared theta equals to 1. Well, this looks very similar to what we were trying to get to, except it's not split apart. So we can now put each denominator, have the 1 on top. So we'd have 1 over cosine theta times 1 over sine theta, and that will equal secant theta times cosecant theta, which equals our right-hand side. So like I said, when we are doing the proving identities, sometimes it's easier because we know where we're trying to get to than when we're trying to simplify expressions.